What are electrical hazards? Mains electricity can be dangerous if safety procedures are not followed. It could include hazards like damaged insulation, overheating cables, damp conditions, excess current from overloading of plugs, extension leads, single and multiple sockets when using a main supply. So, if there was a damaged insulation, then the insulation around the electrical cable is damaged. So the metal part of the wire is now exposed and it can cause an electric shock. If there were overheating of cables, this means that there are excess current flowing through the wire leading to overheating, causing the insulation to melt or even cause fire. If there were damp conditions and if it meets a live wire, then it can cause a short circuit within the device, causing a fire, or it could create a conductive path for current to flow through a person to earth, which can cause electrocution. Excess current from overloading, like having too many plugs or too many sockets in the same place from the same main supply, it will create so much heat that will cause the insulation to melt and cause a fire. In a main circuit, usually you have three openings in a main circuit. One for the live wire, so live wire, neutral wire, and earth wire. The live wire, you need to know the purpose of each one. The live wire, its purpose is to carry the alternating current from the main supply to the circuit. If it touches the appliance without the earth wire, it can cause electrocution. The neutral wire, its purpose is to form the opposite end of the circuit, so to the live wire to complete the circuit. You know that the circuit has to have both ends connected to have a complete circuit. So it goes from live wire, goes back to the neutral wire. Because of its lower voltage, it's much less dangerous than the live wire. The earth wire is what keeps us safe. So it acts as a safety wire to stop the appliance from becoming live. It prevents electric shocks from occurring if the appliance malfunctions or the live wire breaks off and touches the case of the plug. Then all the extra charge will go through the earth wire to keep us safe. User or device protection. How can we do that? Double insulation. If the conducting part of the wire encounters a person, it can cause electrocution. So if we do double insulation, the wires are covered very, very well, such as using double insulation of rubber. Earthing. The earth wire is an additional safety wire that provides a low resistance path to earth. It causes a surge of current in earth wire and hence also in the live wire. The high current through the fuse causes it to melt and break, and this cuts off the supply of electricity to the appliance, making it safe. If the current in the wire becomes too large, the wire of a fuse heats and melts, causing the wire to break and breaking the circuit and stopping the current. A circuit breaker acts when the current of the wire becomes too large. The switch of the circuit breaker just goes off, and when you're sure that the current is now normal again, you can just simply turn it back on, unlike the fuse. You need to know the fuse rating. So if I give you a specific amount of current that is going to pass through, you have to tell me how much or what is the fuse rating you're going to use. So fuses have ratings which signify the maximum current allowed to flow. If the current exceeds that value, the fuse wire will melt and the individual appliance is disconnected from the main supply, keeping it safe. The correct fuse to use is the value just above the current required for the appliance. So if you're using an appliance using 3.1 amps, if you use 3 amp fuse, it's too small. Any current that passes will be too little for the appliance, and if it reached the 3, the fuse will melt. A 13 amp fuse would be too large. It would allow extra 10 amps to pass through the appliance, and it will eventually blow. Maybe a 5 amp fuse would be good, because it would allow 3.1, a bit 4 amps to pass through. It wouldn't harm my appliance, and if it reaches 5, the fuse will melt. Trip switches. The current enters the house at a consumer unit. The consumer unit consists of a series of trip switches. I'm sure you've seen it next to your house door, like an electricity box, and it has a lot of trip switches. They control the amount of current supplied to each circuit within the house. When the current is too high, the switch trips and stops the current flowing to the circuit. Consumer unit distributes current to all the circuits in the house, and their advantage is that they provide protection from current surges or faults, and they can be reset when the problem is fixed. That's all for today. Hope you have a very good day, and please let me know if you have any questions. Bye bye.